In this video is the continuation of the previous topic that tackle about the desk method. For now, let's tackle about the washer method. For the washer method, I have a short explanation about that. If we have here, let's imagine that these two curves rotate along the x and y axis. For the radius of washer method, it has a two radii. First is the inner radius from the center into the inner curve, and we have the outer radius from the center into the outer curve. So it looks like a ring, and it looks like this one. I have here the example of washer figure, because from the center here into the inner curve, that is the inner radius, and from the center into the outer curve, this is what we call the outer radius. So it looks like a ring. So for now, for the radius, we have the two formula. It depends upon the axis of rotation. So we have here, so for the washer method, if the axis of rotation is in the x-axis, so take note, is the volume is given by v is equals to pi times the integral of f of x raised to the second power here minus g of x raised to the second power with respect to x, because the function of our integrand here, it talks about in terms of x, and the axis of rotation is occur in the x-axis. That's why dx here. So E and B here, that located in the upper and lower of the integral sign, that is what we call the limits of integration. Remember that pi here is a constant, so this is already a simplification, and this would be the formula of the axis of rotation is in the x-axis. So for the key points, I have here the radius outer, or the outer radius, is equivalent to the value of our f of x. Supposed to be this is our outer radius. We have here minus the inner radius, or r in. So out minus in. So outer radius minus inner radius. So supposed to be that radius inner is equals to the value of our g of x, and the g of x is equivalent to the value of our y inner. So it is very clear, and let's proceed for the exercises for the washer method. I have here the case problem. Find the volume of the solid obtained by rotating about the x-axis. So we have already the formula that rotate along the x-axis. The region bounded by y is equals to 2x. So 2x here, not I emphasize this one, 2x. This would be 2x. And then we have the secant y that represent of the value of g of x, which is square root of x from the 0 to 2. Suppose 0 to 2 here represent the value of our limits of integration. So let's have a graph in order to figure out and to more understand what problem it talks about. So I have here the axis of rotation is in the x-axis, so this would be the graph. So we have here a two-dimensional figure from 0 to 2. So we have here 2, we have here 2, and then 2 here, and then we have here 1 and 2. So along the x-axis, and we have the interval from 0 to 2, and we have already the value of our y, which represent of our outer radius, which is 2x, and then the y secant y here is represent to the inner radius, which the equal to square root of x. So according to a problem rotating about the x-axis, so this arrow here, the two curve here, rotate along the x-axis about 360 degrees, and what will be happen? So you can form a three-dimensional figure. So at this moment, you can calculate the volume through by a given formula for the washer method, that the axis of rotation is occur in the x-axis. Sorry, excuse me. We have here the inner radius from the center into the inner curve, and we have here from the center into the outer curve. So this would be our outer radius, and this would be our value for calculating this one for the volume of this figure. So let's have a solution. So for the formula, we have here V so V is equals to pi is represented as a constant that equivalent to 3.14 and something. So times the integral of, we have here e to v, represent of our limits of integration. So b here, e to b, with the integral of what is the value of our outer radius, or f of x, or the equivalent of y. So f of x and y and outer radius is equal. So we have here the y supposed to be the value of f of x is 2x. So we have here 2x raised to the second power. Let's put the formula first. So f of x here, and then minus g of x here, raised to the second power with respect to x. So that would be the formula for the x-axis rotation. For now, we can substitute or evaluate the value of our f of x, which is the value of our y as 2x. So we have here pi times the integral of, we have the value of our e and b, from 0 to 2. We have here 2x raised to second power, and then we have here the x square root of x from the inner radius, or the value of our inner y. So for now, raised to the second power, and then with respect to x. So what have you noticed? So what we are going to do is to simplify this one, that we cancel this square root by canceling this power, or raised to the 2, and let 2 distribute to the 2x here, or we can simply 2x. We have here, we can simplify this one, 2x times 2x, so that would be 4x squared. So 2x times 2x is 4x squared. So pi, the volume now is v, we have here v is equals to the integral, we have 4x squared minus x. We can cancel this one, so we left the expression x, so with dx here, and then we have the limits of integration, which is 0 to 2, and the volume now is equals to the integral of this function, because we can simplify this one by getting the integral of this inside the integrand. So what is the integral of 4x squared minus x? So the integral of 4x squared supposed to be the pi times the function that equal to the integral. This one is 4x to the cube, and then 3. We have here 3 because we have put plus 1 here, and then 2 plus 1 here, So 2 plus 1 in the denominator is 3, and then 2 plus 1 here, and this would be x cubed. Minus, what is the integral of x is x to the 2 over 2, because we have here the constant 1 plus 1, that would be 2, and what would be the exponent that also or our denominator, so 2 here. Evaluated 0 to 2. For now, we can simply evaluate by using the sorry, I put the line here. So I finalized this one, so this would be 5 times the integral the function, which is the integral of this one. So 4x cubed over 3 minus x squared minus 2. Evaluated 0 to 2. So let's evaluate now for for getting the volume of our problem. So the volume now, V is equals to pi by using the definite integral principle, which is BFB minus FA. F here represent of this function here, and B evaluated B and A. See, so this would be 2 here. So 4 to the 2 raised to the third power over 3, and then minus 2 to the 3 over 2, and then we have minus 0. So the volume now, sorry, I replaced this one into this one. V is equals to pi times this function. So 0, because if we evaluate this one, 4 0 to the 3 is 0 times 4 is 0 over 3 is 0. So 0 to the 2 is 0 over 2 is 0. 0 minus 0 is 0. So our concern is this function, which is the equivalent of our f and v, fv. So for now, we can simplify this one into the 2 to the 3 as it, and then 2 to the 3 as also it. So this would be the volume now is equals to pi times 4 times 8 over 3 we have here, and then minus 8 over 2. So for now, we can simplify this one to 4 times 8. So 4 times 8 is 4 times 8 is equals to 32. So our V now as B is equals to pi, and then 32 over 3 over minus 8 over 2, or we can simplify this one into 4. 8 divided by 2 is 4, so it's no longer 8 over 2, this would be 4. So if we can simplify this one, 32 over 3, so let's try this one. 32 divide 3 is equals to so at this moment we can simplify this one into by doing for getting the less common denominator. So this would be V is equals to pi. What is the lowest common denominator? Always remember that whole number have a denominator 1. So our least common denominator is 3, because 3 times 1 is 3. 1 times 3 is 3. So that's why 3 is our least common denominator. So 3 divided by 3 is 1 times 32 is 32. Then we have 3 divided by 1 is 3 times 4 is 12 minus 12 here. So this would be 32 minus 12 is 20. So 20 over 3 So the volume now is equals to V is equals to pi. V is equals to pi times this function. And we can simplify this one through by convert into a decimal function. So if we multiply this one pi times 2 over 20, as we can get 20 times over 3 is equals to 6.67 times shape and then pi. We have here 20 point, the volume is equals to 20.94, or we can simplify this one into V is equals to 21 units cube. So the volume of a given figure, which is the represent the figure of a washer method, by applying the washer method, this would be the washer figure. We have here the outer and inner radius. So the volume is equals to 21 units cube by a given that outer radius is 2x and the inner radius is square root of x with the interval of from 0 to 2. So this would be the volume of this 3D figure. So thanks for watching, and don't forget to subscribe Pilans 57 CFD channel and Hanip Buhay, and then Hazel Dragon YouTube channel.